Hello everyone, so welcome back to our YouTube channel. So today's question of 75 days LeetCode series is can place flowers. Okay, so we are given a flower bed array in which some of the plots are planted and some are not, and it is a condition given that we cannot plant adjacent plots. Okay, so in this array, 1 means that it is already planted and 0 means it is not. So we are given a n, which means how many we have to plant. So we just have to check how many flowers we can plant given the condition that we cannot plant adjacent flowers. Okay, so now we have understood the question. So as per the example, this is 1 0 0 0 1 and n is 1, so it is giving true, which means where we can plant it here. So it will be 1 1, it will be 1 0 1 0 1. So yeah, it is valid since there are no adjacent flowers planted. But in the next example, n is given as 2, so we have to plant 2. Since it is 1, it is 0, but we cannot plant here since 1 is already adjacent to this. We can plant 1 here, but then n will be only be 1, not 2, so it is giving us false. Okay, now we have understood the question. Now let's come back to our uh, approach and intuition. So as we are given example of, let's say we are given example 1 0 0 1, okay, and n is 1, so it means that we cannot plant here, we can plant here, we cannot plant here. So what it will look like, it will look like 1 0. Okay, similar in the another example we are given 1 0 0 1. Okay, but in this we cannot plant 2, since if we plant it here and here, it will not be a valid flower bed, and we cannot plant it here and here also. So as we can see in the like all the examples, like in this case, let's say this 1 0 1, and for any n it will not be a valid, because if we place it here it will be adjacent to these both. So in this case, let's say we have two zeros in an array. In this case also we cannot plant anywhere, since it will be like adjacent and it will violate the condition. Okay, but in case we have three zeros, we can have in one in the middle. Okay, we can have one in the middle. So as per these we can like confirm that we will be requiring three positions. Okay, so we will be requiring three positions where we can check if the current is like, if we can place it at the current position, and if the previous one is also not planted and the next one is also not planted. Okay, so three adjacent zeros will be required, for which we'll be checking if the current is not planted and previous one is also not planted and the next one is also not planted, then we can plant in the middle. Okay, but there are some edge cases. If it is given 0 0 and 1 and n is given as 1, since in the earlier questions we discussed that if we are given two uh, subsequent zeros, adjacent zeros, we cannot plant since it will violate the condition. But in this it will be valid if we place it at first position, right? It will be a valid one. Similarly, if we are given 1 0 and 0, so we can plant it at the end. Okay, right? So these are some edge cases where the like it is not planted at the initial stage and at the last stage. So what we can assume in these both types, we can assume there is a zero at the end, and in first we can assume there is a zero before it. So therefore we it will be like valid we will check if it is present before or not and present after that. If like not planted both, then we can plant it here. Similarly, if it is not planted here and not planted here, then we can plant it here. So like this is the only intuition behind it. Okay. So yeah, I think we can so the pseudocode we can try for this. So what we will do, we'll just check if like the ith position is 0. Okay, and array of I minus 1 and an array of I plus 1. Okay, they all should be 0. There are some edge cases that we have discussed, so that edge cases will be like uh, equal to when ith will be a zeroed position, then we can consider it, then that it is all we can plant it in the previous case. And in case I is equal to n, then it means that we can plant it at the last stage given that the previous one is equal to 0. Okay, yeah, so I think so the time complexity, so the overall time complexity in this will be big of n, since we are iterating over the array only once, and the space complexity will be big of 1, since we are just using variables, not anything else. So yeah, we can go for the coding part. Yeah, we can start with the coding part. Yeah, so let's just take one counter variable which will count the number of instances where we have like captured how we can plant. Okay, so yeah, okay, now we will iterate over the array int I equals to 0. Okay, now what we have to check if the we can plant at the current position. Okay, since if it is already equal to 1, there's no need to plant at that position. Okay, so now what we have to check, we have to find the previous value and next position value. Okay, so now what we can do, we will find our next. Okay, so it will be if okay, so for the next value, if it is at the end that we have discussed, if it is at the end, then we have to assume there is a 0 at the next. Then if this is 0, then we can check if I is equal to last index value. Okay, last index basically. So if it is last index, we have to assume that the next value is 0. Okay, else what we can do it is flower bed I plus 1. Similarly, for calculating previous, we have to check if I is equals to 0, like 0th index, then we have to assume we have already assumed that the previous value of this is 0. So if I equal to 0, then we have to assume the previous will also be equal to 0, else it will be flower bed I minus 1. Okay, now we can check if previous equal to 0 and next is also equal to 0. Then what we have to do, we have to update our counter and we have to update the array basically at that ith position that we can plant it, so that for the next ith position we can validate the same. After completing the loop, we will check if the counter is we as mentioned the question, we have to return true if n new flowers can be planted. So in case the counter comes out greater than the given value, we have to also return the true, right? Because we can plant n, it can be greater than n. So in case counter is greater than equals to n, we will just return, it will just return true, else it will return false. Okay, now I will check if it is validating for this. Now we can take one example. Basically, one, okay, 1 0 3 zeros, then okay, now it is, we can plant one at this position and one at this position, so we can plant two, but if it is one only, it is working fine, it is giving expected as true, and our output is also true. So now we can submit the solution. Yeah, it is working as expected. Yeah, so thanks everyone for watching. In case you do like this video, please do subscribe our channel for more and latest updates. Yeah, thanks everyone.